Okay. A very good morning to all. Last class we discussed regarding a public key cryptography. What are the rules that we follow? And before going for public key cryptography, I said that the presently in symmetric key cryptography or a single key or a private key, we have two problems we have. One is key distribution, how to save how to have a secure communication, that is one problem. So next one is digital signature. The received person will not have any idea whether the received message is from a proper authorized person. So digital signature is a problem in symmetric. To overcome that, we went for public key cryptography. We went for public key cryptography. So public key cryptography, also known as, listen all of you, public key cryptography also called as two key cryptography or asymmetric key cryptography. It uses two keys. One key is public, which may be known by any all the persons in the communication in the network, and can be, this is used for encrypting the message and to verify the signature. And a private key is only known to the recipient, used to decrypt the message, and is used to create a signatures. In asymmetric key, because is it is asymmetric because those who encrypt the messages or verify signatures cannot decrypt the messages or create signatures. So the problem, let me revise once again. The problem in symmetric key cryptography is that there is a key distribution problem, and uh, one more is digital signature. So to overcome that, we are using a public key cryptography. So in a public key cryptography, we are using this. This can be classified into three categories. One is encryption and decryption, and one is used for providing a digital signature, and one is for key exchange, session keys. What are these session keys? I will explain. It's like a one-time OTP message, like that. So some algorithms that we will discuss in this public key cryptography is, first one, which is very famous algorithm, is RSA. So what RSA will do is, it supports encryption and decryption, it supports digital signature, and it supports key exchange. This is one of the very important question. Listen all of you. So public key applications can be classified with into three categories. One is, it can you can provide secrecy, confidentiality by encryption and decryption. The next one is, you can provide digital signature, it provides an authentication. Next, yeah, this two we already discussed for the previous class. And next one is key exchange. So this is like a session key, one time key is used for encryption and decryption. So some algorithms are suitable for all uses. So like which is one which is very famous is RSA algorithm. So in this, it supports encryption and decryption, yes it supports. Digital signature, yes it supports. Key exchange, yes it supports. So elliptic curve, Diffie-Hellman digital signature standards, DSS. This RSA is only used for it will be used for all three, but in our syllabus we have Diffie-Hellman, so it only supports key exchange. So Diffie-Hellman is not used for confidentiality or authentication service, it only used for exchanging the key. So for what purpose Diffie-Hellman is used is, it is used for exchanging the key session, it is used for key exchange only, yes. So for the remaining cases, is it used for encryption and decryption? No. Is it used for digital signature? No. So next one is DSS. So DSS is only used for digital signature. DSS is digital signature standard, so it's only used for digital signature, it's not used for key exchange or encryption and decryption. Whereas RSA supports encryption, decryption, digital signature, key exchange. Okay. So description of RSA algorithm. So try to understand carefully. Today's concept is, we will study about RSA, but you should know the previous basic concepts of public key cryptography, then you can understand clearly. Okay. So RSA makes use of expression with exponentials. It will be like the plain text power exponential. P power E, like a ciphertext powers, exponentials will be used. I will explain that. So plain text is encrypted into blocks. Same like in a symmetric key, what we have done, we have selected it is a block cipher. We have selected the block size, and this block size we have encrypted. And at this, the receiver side, we are decrypting with the block size. Here also for RSA, it is a block. A plain text is encrypted in blocks, with each block having a binary value less than some number n. So here, based on the n value, it decides a block. So it should be less than n. It should be less than n. What is this n? I will discuss, but note down in your notes. It should be the binary value less than some number n. So see here, uh, the most common public key algorithm is RSA. So why this name called RSA is, it is invented by three Rivest, Shammer, and Lemon. So these are the three. So started with the start RSA. So this is your RSA. So it uses two keys. So one is public key and the private key. Everyone knows that public key need to be shared and then to the users who are communicating in the network, and the private key must be secure. Okay. So in this the two keys E and D have a special relationship to each other. So what is that, we will discuss now. Okay, but try to keep it in your mind. E is your public key and D is your private key. Now this RSA is used for providing encryption and decryption. For that, encryption and decryption is confidentiality. Just now I said that it will be of three categories. One is encryption and decryption, and the other one is digital signature, and the other one is key exchange. So if you want to provide encryption and decryption, it provides secrecy, means confidentiality. So in a confidentiality, yesterday's class we discussed about public key cryptography. So in public key cryptography, for providing confidentiality, with which key we have to encrypt the message and with which key we have to decrypt the message. Can anyone? With which key for providing a confidentiality, we need to encrypt the message? Anyone answer please? For providing
Public key of receiver
yes, good. So
and,
public key of receiver
and
and with
private
which
key.
private key of receiver. Okay. So Alice wants to encrypt a message. Okay. So this we are encrypting with public key of receiver. So public key PU with the starting letter of the receiver B. So this is your public key of receiver, and it has to be decrypted with the private key. That's the reason that I said to revise once. This is PR is private key, and based on receiver, sender or receiver, the starting letter it is B. It is decrypting. For that, so is I need to know if an Alice wants to send any message to Bob, Alice has to know the public key of Bob. First question. Okay. So for that, what Bob has to do, Bob has to create a pair of keys. Okay. So pair of keys. Okay. So in this pair of keys, Bob has to broadcast what? Public key. Okay. Then Bob has to create its own public key, has to be shared. This public key has to be shared in one centralized directory or some registers. Everyone's public key will be shared. So whomever wants to communicate with the Bob, they will check this directory and will take the public key of Bob and will encrypt this. So here main concentration is receiver. Okay. So receiver has to broadcast its public key and a private key has to be secure. Only Bob must know the private key, whereas a public key has to be shared so that the Alice will use his public key for encryption, and for decryption, Bob will use its own private key for decryption. This is the process. For that, what Bob has to do is Bob has to share a public key. So for that, what we are doing is, so here E is used for public key, means what Bob has to do, consider Bob is a receiver, so Bob has to share this public key so that Alice can use this public key for encryption. So along with E, Bob will also share N. So what is this N? Just now I said that with each block having a binary value less than some number n. So this n will also be shared so that the sender will decide the plain text size. It should be less than n. Okay, so the two keys E and D is a private key, E is a public key. Concentrate. Next, see here, this is a diagram. Using this you can understand very easily. And Alice and Bob, Alice wants to encrypt a message. RSA, here we are using encryption and decryption confidentiality. I want to provide confidentiality using RSA algorithm. But public key cryptography, you have three. So what are those three? First one is encryption and decryption, second one is digital signatures, and the last one is for providing key exchange. Okay, so for providing only key exchange we are using what? Diffie-Hellman. For providing encryption and decryption we are using RSA, and for providing what for providing digital signature we are using called digital signature standards, DSS. Okay, so even RSA can also be used, and RSA can also be used for key exchange, but now we are discussing about encryption and decryption. Okay, so now Alice wants to communicate with Bob. So what Alice will do, Alice will take from the centralized directory a public key of E and will encrypt. So how it encrypts is ciphertext. How ciphertext is generated is plain text. Just now I said that it uses exponent, right? So makes use of expression with exponentials. Okay, so it uses exponent, means P is your plain text and pa E is your public key, and mode n is your number where which is shared by Bob itself. If they are using an agreement that we will use an RSA, Bob will broadcast it along with the public key. It also shares a n value, so that Alice will get n value. So what is that n value? We will discuss clearly, but try to understand. Bob, along with the public key, Bob will also share n value. So here, plain text is what? Plain text is a message that Alice wants to send. That should be less. This p should be less than your n value. So if n is 64, and it should be the plain text should be less than that. That is one thing you need to concentrate here. So plain text is encrypted in blocks, with each block having a binary value less than some number n. Okay, so as it takes from the directory n value, so C equals to p power n mod n. Okay, so you will be generating a ciphertext will be generated. That ciphertext will be shared to Bob, and what Bob will do? Bob will, here it is wrong mark. It is C power d. See here, this is C power d. Okay, so plain text. How Bob will decrypt that ciphertext is using D. So as just now we discussed, E is a public key, D is a. Let me write here so that you can understand. At last, I will ask you the question, so try to concentrate. So this is your task. So what Bob has to share? Bob has to share E is public, D is private. This concentrate, this E is public, so this has to be shared, and D is private. This should not be shared. This should be kept secret. Okay. So now along with E, it also shares n value. So what? How this message will be encrypted with? See how you will get a ciphertext is you are encrypting with what? You are encrypting with the message with the public key. So what is the formula for that? C, how we are generating a C? C equals to, how we are getting C? C equals to P. P is your plain text. Let us suppose the plain text that you want to send is 12. So 12 means internally there will be some value for that plain text 12. E is your public key, mod n. So you will be generating what? Ciphertext. So next is what? Using public key of Bob. Alice will encrypt this with plain text par E mod n. Okay. Now Bob has to generate a plain text P or a message. It depends upon, we can even say M, or we can say P. Okay, so how P will be generated means the C has to be converted to M or P, message or a plain text. So how is, so C, Bob will get a ciphertext C. Pa, it has to get what? D. D is a private key. So why? Because at this side I already said that it has to be decrypted with Bob's private key. So it will be decrypted with Bob's private key with exponential D mod n, mod n. So that what Bob will get? Bob will get a plain text M. Bob will get a plain text M. These two are very important, ma. Plain text ma, E is your public key. N will also be shared by the Bob. So P power n mod n, so that this message will be converted to ciphertext. Next, in order to get from ciphertext back to the plain text, what Bob will do? Bob will decrypt with its own private key. So ciphertext part D is the private key mod n, so that the Bob will receive Bob will convert the plain ciphertext to plain text. Okay, is it clear? Is it clear? I will explain with the steps, but try to understand until this point. So E will be used. This is a public key. D is your private key. So C equals to P par E mod N for decryption. B equals to C par D. Not E here. It is D. So C par D mod N. Okay. So in this way, the sender and receiver encrypts and decrypts a message, and Bob will be, with the help of a private key, will get a plain text. Okay, so these are the steps to follow in order to find out the plain text by the Bob. So first step is what? Everything has to be done by Bob or everything has to be done by Alice? First point, are we using Bob's public and private key or are we using Bob's Alice public and private key? First answer, Mima. Are we using Alice public and private or are we using Bob's public and private for providing confidentiality? Answer. Yes, ma'am. So which keys we are using, Bob's or Alice?
Bob.
Bob. So we are using Bob's public and private key for providing confidentiality. So here, Bob uses the following steps to select private and public key. So what are the steps? You know down. So these are the steps to be followed. So first step is what? Bob chooses two very large prime numbers P and Q. Okay. So two very large prime numbers P and Q. The larger the prime numbers, say it will be more secure. So next is what? Bob multiplies P and Q to find N. Just now I said that what Bob will do? Bob will share along with the public key E will also share N. So how this N value is calculated is Bob multiplies P and Q to find N. So N is what? N equals to P into Q. Next is what? Bob calculates another number pi of N. So pi of N is P minus 1 into Q minus 1. Okay, so this, with the help of selecting the prime numbers values, we will discuss, but try to understand. Note down here, I will ask you the questions next. Next is Bob choose a random encryption number E. So this E, how this Bob selecting E is what? Is it a private key or a public key? E. Yes? E is what, ma? Is it a public key or a private key?
Public.
Yes, E is a public key. So how this E is selecting is, E should be in such a way that it should be 1 should be less than, E should be less than pi of N. So that means GCD of E and pi of N is equals to 1. So what is this pi of N is? P minus 1 into Q minus 1. So you will get some value, and the GCD is greatest common divisor of E comma. The value that you are selecting E, the GCD of that should be equal to 1. That is the main rule. So it should be in between 1 and pi of N. If pi of N is 20 or 40, let us suppose, it should be between that, and it should be the pi of N and E value should be equal to 1. So that you need to find. So E should be selected by Bob. This all is done by Bob. Why? Because Bob has to share the public key after calculating this all. Bob has to share its public key after calculating this all. So he then calculates D, so that D is a private key. So he then Bob will then calculate a D, so that D into E mod pi of N equals to 1. Okay. Next, after completing everything, Bob announces E and N to public. Just now I said that along with the public key, Bob will also share N to the public. okay, to the public. He keeps which one to be secure? The private key must be secure. D is the private key, and even he keeps secure pi of n value. He secures pi of n value. So he keeps pi of n and D as secure, and E and N to be public. Means there will be central directory or there will be some register. In that register, he announces, Bob will announce, this is my public key and this is the n value, so that whomever wants to communicate with me, try to use this public and n value for encryption, so that I will use my private key for decryption, D. Okay, so this is the RSA encryption and decryption. Just now with the help of a diagram we studied RSA encryption and decryption. So this is for encryption. So we are encrypting C equals to P power A mod n, and decryption P equals to C power D mod n. E is your private key, D is your E is your public key, D is your private key, N is your N should be what value? So n should be selected in such a way that it is PQ. PQ will be selected by, see here once again I'm saying, P and Q are the prime numbers will be selected, and how n value you are getting? N value you are getting by multiplying P and Q. So you will get n value. Okay, so this is your value. So just now I said that P should be less than n. If not, the plain text need to be divided to blocks to make P less than n. Okay, if it is greater than, what we have to do? If the message of the if the message that the sender wants to send to the receiver, if that message is long, what we will do? We will divide that into block size, and first block we will use that encryption algorithm. Next, for the next block we will use the same. So in the same way, if the plain text that the sender wants to send is larger than the n value, we will divide that, and the remaining one we will use the same concept for encryption and decryption. Okay, so next is what? These are the general that we discussed here. Key generation, select P and Q prime numbers, both should be prime numbers, calculate n, and pi of n, calculate pi of n. I will ask you the questions, note down. P and Q prime numbers, n is P into Q, pi of n is P minus 1 into Q minus 1. Select E such that it should be 1 in between 1 and pi of n, and the GCD of pi of n and E should be 1. Okay, and you need to calculate D. So calculating D is what? Calculating D is DE mod pi of n equals to 1. DE mod pi of n equals to 1. Okay, so this is your public key pair is E comma N, private key pair is D comma N. Okay, this is your encryption side. Ciphertext will be generated, message we can even say as P or M, no problem. So message E mod N. For decryption, how can the Bob will get a plain text M is C power D mod N. So I'm repeating twice and try to understand. Now let me start with an example. So I'm selecting two prime numbers. One is 3 and the other one is 11. So two prime numbers. RSA algorithm example, choose two prime numbers, P equals to 3 and Q equals to 11. Next is what we are doing? We are calculating n. So why? Because Bob has to share its public key and the n value, so that Alice can encrypt with the public key. Okay, so what Bob is doing, these all steps are doing by Bob, by the receiver, so that Bob will share a public key. So it is started with RSA, started the first step called choosing two prime numbers, one is 3 and the other one is 11, and compute n value. So how to compute n value? N value is P into Q. So P is 3, Q is 11. So we are multiplying that, we are getting 33. Okay, so now n value is 33. Now n value is 33. Next step is what? Now n value is 33. Next step is what? We need to choose E value. So E is 7. So can anyone tell me GCD of E comma, what should be GCD of what should be my GCD of E comma something should be equal to 1. What is that? GCD of what? Fast. GCD of E comma GCD of E, and the other one is what?
Pi
And
of
the
n.
other, yes, GCD of E comma pi of n should be 1. So for that, we for finding the GCD, it takes more time. For that, in this we are using Euclidean algorithm for finding that. So that Okay, so we need to find E. E is a public key of receiver. So we need to calculate E, and it should be co-prime, and the is one should be and pi of n, and the other rule is the GCD of pi of n comma E should be equal to 1. Okay, so for that we are using Euclidean's algorithm. So for finding the GCD, so in this, just a minute, no? So in this what we are doing is we are finding GCD. So GCD of A comma B. Okay, so GCD of A comma B, let me consider 20. What we have here, uh, pi of n is 20, so I've selected 20. So we started with 3 and 11, so n value is p into q 33, and pi of n is 20, so we have selected pi of n as 20. 20 pi of n comma E, so pi of n 20 is will be acting as A, and E, let me consider the same one, which is taken here as 7. So we will see whether it is equals to 1 or not. So 7. Okay, so this is your GCD, and according to Euclidean algorithm, what we have to do is GCD, the formula is GCD B comma A mod B. Okay, so B is here what? A is 20, B is 7. So GCD of 7 comma A is 20, 20 mod 7. Okay, so which is equals to GCD of 7 comma, what is 20 mod 7, man? What is 20 mod 7? Fast answer me, ma, fast. What will be the answer? 20 mod 7. What answer we will get? What is the answer? 20 mod 7.
Six.
Huh? Huh?
6.
Okay. So now again base. Okay. Now again this will be acting as A. This will be acting as B. Again using this Euclidean algorithm, what we have to do? GCD of uh, GCD of B. B is 6, and 7 mod 6, which is equals to, what is 7 mod 6 fast? Which
1.
is equals to GCD of 6 comma 1, 6 comma 1. So this is your A and B. Now again use the Euclidean extension GCD algorithm. So first will be B and second will be A mod. So GCD of, now what is B here? What is B here?
1.
1 comma 6 mod 1, which is equals to GCD of 1 comma
0.
0. So when 0 comes, you have to stop. This is your result. When 0 comes, you need to stop, and the one which is left out is 1. So now yes, this is the correct answer. Means what? We know that GCD of 20 comma 7 is 1. So 7 will be, we can select 7. So try to select all possible values so that it should be equal to 1. So in this case we have selected what? We have selected E value as 7. So the GCD of pi of n formula is p minus 1. So p is your 3. 3 minus 1 is 2, 11 minus 1 is 10, so you will be getting 20. So GCD of pi of n 20, and we selected 7. So after calculating, we got the value as GCD of 20 comma 7 as 1. So we can select the value as 7. Okay, next step is what? This is using Euclidean algorithm. So you have to follow. Why? Because the common GCD is not used in RSA. Why? Because as we should not select these small numbers, so it should be a larger number, so that you will provide a more security. For sake of understanding, we are going for small numbers. Next is what? The next step is what? So calculated an e value, calculated an n value. So e value and n value will be shared in the central register, so that Alice can use this for encryption purpose. Next step is what we need to calculate? Bob completed calculating public key e and n. Next, what Bob has to calculate? What Bob has to calculate?
Private key.
Yes, okay. So Bob calculated a public key and is shared. Next, Bob has to calculate its own private key, so that this private key can be used for decryption purpose. So for that, what is the formula is d into e mod pi of n equals to 1. So such that the d value should be selected such that the d into e mod pi of n should be equal to 1. So for that, what we have done, so e value is 7, so what we are doing is, in if we have here anyhow pi of n as 20, so if you have 21 here, then we will get the value as 1. So what we have done, so we have done as we selected d value as 3, so that 3 into 7 you will be getting 21, mod 20, which is equals to 1. So the Bob has calculated d value also. So all calculated, e value calculated, d value calculated, n value calculated. Now the Bob has to pair. E comma n is used for, see here, e comma n is used for public key, d comma n is used for private key. Why? Because here e m power e mod n, m power e mod n, and c power d, and c power d mod n. Okay, but now the problem here is, for calculating d, this is not the right solution. Again, for calculating d, internally it uses Euclidean extended algorithm. So what is that? How to calculate this d value? I will explain in the next class. So thank you, ma'am. So let me stop the recording.